Look around the world today, and you'll see something remarkable. Human skin comes in almost every shade imaginable. Deep brown, pale white, every tone in between. Most people assume the story is simple. Early humans were dark-skinned, then some of them slowly turned white as they moved north. But new evidence tells a very different story, one that took far longer and took a far stranger path than anyone expected. Here's the first surprise. Our earliest ancestors likely didn't start out dark-skinned at all. Scientists believe that before humans lost their body hair, their skin was actually light, protected from the sun by thick fur, much like a chimpanzee's skin is pale underneath its hair. It wasn't until humans began losing that hair that skin color became a matter of survival. As early humans evolved to sweat more efficiently and hunt across open, sunlit landscapes, they gradually lost their body hair. This helped them cool down during long hunts, but it created a new problem. Their skin was now directly exposed to intense equatorial sunlight, and that sunlight could be dangerous. Strong ultraviolet rays don't just cause sunburn. They can break down folate, a nutrient essential for healthy pregnancies and cell growth. So evolution found a solution: melanin. This natural pigment darkened human skin, acting like an inbuilt sunscreen, protecting the body from UV damage in the sun-drenched regions near the equator. For a very long time, dark skin was the norm for humans everywhere. Around 60,000 to 70,000 years ago, groups of humans began migrating out of Africa. They moved into regions with weaker sunlight, shorter days, and colder climates. Here, the same dark skin that once protected them created a new challenge entirely. Skin doesn't just protect the body, it also produces vitamin D using sunlight. Vitamin D is essential for strong bones and a healthy immune system. But dark, heavily pigmented skin blocks more sunlight, making vitamin D production far harder in places where sunlight was already scarce. In these northern regions, natural selection began favoring something new. For decades, scientists assumed this transition happened quickly, that within a few thousand years of arriving in Europe, humans evolved pale skin to survive the weaker sun. But that assumption turned out to be wrong. Recent studies analyzing ancient DNA revealed something nobody expected. Researchers studied the genomes of hundreds of ancient humans who lived across Europe between 45,000 and 1,700 years ago. What they found was surprising. Even 5,000 to 3,000 years ago, thousands of years after humans first arrived in Europe, about half the population still had dark or intermediate skin. From Spain, who lived roughly 7,000 years ago, still had dark skin, paired with strikingly blue eyes. Light skin, it turns out, was still rare at that point in history. It wasn't until around 3,000 years ago, during the Bronze and Iron Ages, that lighter skin finally became the dominant trait across much of Europe. That's tens of thousands of years after humans first settled there. Far slower and far messier than the simple story most people have heard. So if it wasn't just about sunlight, what else was driving this change? Scientists now believe diet played a major role. Early hunter-gatherers ate large amounts of fish and wild game, foods naturally rich in vitamin D. But as agriculture spread, diets shifted toward farmed grains and crops, which contained far less vitamin D. With less vitamin D coming from food and less sunlight available to produce it naturally, the pressure to evolve lighter, more sunlight-absorbing skin grew stronger. It was two separate pressures arriving together that finally tipped the balance. Here's another twist. Lighter skin didn't evolve just once. Populations in East Asia developed their own separate genetic path to lighter skin, completely independent from Europeans. Different populations on different continents arrived at similar outcomes through entirely different genetic routes. Perhaps the strangest discovery of all involves eye color. Some ancient Europeans had dark skin paired with blue eyes, thousands of years before light skin became common. This suggests that skin color and eye color didn't evolve together in a neat matching package. They changed on their own separate timelines, shaped by their own separate pressures. Understanding this history isn't just an interesting fact. It helps scientists and doctors understand modern health differences, like vitamin D deficiency, which still affects people with darker skin living in low sunlight regions today. It's a reminder that skin color is not a fixed marker of ancient identity. It's a flexible, ongoing adaptation, still shaped by where humans live and how they eat. So here's what we now know. Human skin didn't move in a straight line from dark to light. It shifted slowly, unevenly, shaped by sunlight, migration, diet, and time, taking far longer and following a far more complicated path than the simple story most of us grew up hearing. Skin color is one of the most visible features of being human, but its story isn't about one group changing into another. It's about all of us, adapting again and again to the world around us. The next time someone tells you the story of human skin color, remember the truth took thousands of years and countless small adaptations to unfold.